Here we have a Zenith Royal 200 transistor radio from about 1958, and it doesn't work. I've put batteries in it, and I don't even hear anything from the speaker. So I'm going to open up and see what the problem is. The radio is opened up with these two screws, two brass screws, and the back should come off quite easily. Just turn them over, and the radio comes apart. I'm just going to put the screws as I take them out in the pill bottle so I don't lose them. The manufacturer made it convenient, as you have very good documentation on the back here. Oops, it's kind of hard to the lighting on it, but what it does is it tells you how the batteries go in, if you're using penlight or mercury cells, and there's a schematic, kind of a, I guess you'd call it more of like a diagram that shows which IF bin is which, and it shows you where the transistors are and its part number. So I'll put batteries in, and I'll double check to see if I can get any sound out of it. So I put the batteries in according to the schematic, or according to the diagram on the back. So now let's try it again and see if it makes any sound. No, we're completely dead. This radio is numbered, it's a chassis 7AT48Z2. So I will print out a schematic diagram of that and see if I can perhaps determine by looking at the schematic where I should check first. Here I've tried to zoom in on some of the details of the circuit board, and here's a transistor, here's one, here's another one, and there's 3 more. So these transistors are mounted at the top of the board, and they protrude through the board and are mounted in such a way that the leads are drooped over and then attached to the lands on the bottom of the board. I've never seen that configuration before. It's kind of interesting. Anyway, I'll see what I can do about printing out that schematic diagram. Here I've got the full schematic of the radio, and it's quite conventional for a radio of that era, but I think I'll point out a few interesting characteristics of it. Unlike later radios, this has a separate oscillator transistor here and the conventional mixer. Now this circuit here is an Armstrong oscillator, and you can see this part of the tuned circuit. This dashed line shows that it's connected physically to this part of the tuned circuit. This is the IF. This here is the variable IF. This creates the intermediate frequency, which is 455 kilohertz above or below the incoming signal. Now, this is your loop stick antenna here, and when you tune into a frequency like 1000, this here will have that frequency tuned in, and this will be tracking 455 kilohertz above or below, and this oscillator will be giving you that frequency, and this capacitor takes off a little bit of that frequency and feeds it onto here, which goes into the base of the transistor. So this transistor is receiving the frequency that is tuned in here and the frequency that is tuned in here, and they mix in the nonlinear reactance, nonlinear impedance of the transistor. Then you have all those frequencies fed into the first IF transformer, and the first IF transformer filters it out and only lets 455 kilohertz through. It filters out all other frequencies. You have, when you mix two frequencies together, you get the sum, difference, and the original frequencies that were fed into it. So 455 kilohertz is the only frequency that you will be amplifying from here on. So this is the first IF. It's filtered even more. This is the second IF, and then the signal comes out of the third IF transformer, and it's rectified by the diode here, and you have audio coming out here, and that's fed through this electrolytic capacitor to the first audio transformer or driver, and then the audio signal is increased in strength and is then fed to the push-pull output transistors, and then through the final transformer and into the speaker. Now, I can see right off here that what I'm going to have to replace these electrolytic capacitors. There's no way around it. This one is the coupling. These two are for stabilizing, and this one here is for the intermediate, or not the intermediate. This one here is for the automatic volume control. You develop a DC signal across here, and that's fed up to here to change the bias on this transistor and also the gain. So if you have too strong a signal, the gain of this transistor will be lowered, and if you have too weak a signal, the gain will be increased. So it cuts down on overloading. So the first thing I think I'm going to check on this is this switch here on the volume control. I'll see if any of the voltage is getting through to here. Sometimes these switches on volume controls, they tend to go open, and so that's the first thing I'll check. So I took off this, and this little brass nuts, and I took off these to the volume control, and tuning control. I'm going to have to do something about this. I'm going to have to paint this or coat it back so it's silver colored again. Put them aside so that I don't lose them. It looks like this has never been worked on. All its original components and a good sized speaker. I removed these 4 screws to separate the speaker because it's getting in the way, and then I have access to all the controls here. Sometimes these can cause problems and you get no sound coming out of them. But the first thing I'm going to do is to check the continuity of this switch here and see if the circuitry is getting power. So in this mode, I've got this meter, ohm meter, and I've got, here is the power lead that comes from the battery, and here this is the switch, and just look at we'll see if it's there. I turned on and you see there's continuity, so that switch is okay. So here I am checking the voltage from the battery through the switch on the volume control, and it's showing me there's almost 3 volts there. So the voltage is getting through to the components. So here I'm going to go to a transistor, and we have voltage there, and we have voltage there, and voltage there. So I would assume that certain parts of this are working. So I'm going to go and get an oscilloscope, and I'm going to look and see if there is any audio coming out of the diode. So here I'm taking, I've got one side of the oscilloscope to AC ground and the other to, if you can just see it in there, down there. Let's just move it over here a bit. There's the other side of the diode. You might just be able to see it in there. It's hidden behind this transistor. But anyway, I'm taking a signal from the diode, and I'll turn off the light here to show what it looks like on the oscilloscope. So on the oscilloscope, there, back there, I'm turning all the way through, and I should see a bigger waveform when I am receiving a station, but I'm not seeing anything. So this is dead. So the next thing I'm going to do is I'm going to check and see if there's any signal at the oscillator transistor, and then I'll work my way through. So I'm wanting to check and see if the IF oscillator is working. So I want to check at this point here, where it comes into this 1K resistor and then goes to the coil. So at that point I should be able to see the entire frequency when it's at when it's tuned to 1400 and right down to 550. So let's check that. I've now got the oscilloscope hooked up to that point there. Just get a little closer there. You can see the probe is hooked up there. And now look at the oscilloscope. Move that a little in there. Turn off the light. And you can see that oscilloscope is measuring a healthy signal there. And when I'm at one end right now, and as it spreads out, I'm seeing a lower frequency signal there. So the highest frequency that it is reading there is just over 2 megahertz. So this oscillator is tracking above the frequency tuned in. So that section tests out working okay. The next signal I'm going to look for is the combined signals. So if I might do this differently. I might inject a 455 kilohertz signal and see if it goes through all the stages. So I might even bring up start using a signal tracer. That might be a better idea. I'll use the signal tracer to see if I hear anything anywhere between the diode, and I'll start working my way back. So I've decided to use this ICO signal tracer to go through the stages and see if there is any signal being lost there in the IF stages. So what I'm going to do is I'm going to start with right at the diode just before it detects, and then I'll work my way back. So here we have the signal generator hooked up, and I'm going to take the probe and I'm going to go right where the diode, the detecting diode, goes into the before it goes into the first driver transistor. So let's just poke around there. Oh, we have sound.
At the airport. Now, do you agree with him? Think about it. Now over the break. A 2-drink max at the airport. Should you be allowed to drink more than that?
That sounds pretty good.
We'll talk about that on the other side. This is Mike Smith at Columbia. Shay Ganem is in Alberta. Kelly Couture in Ontario. More on Crosstalk.
Okay, so what that proves is that all of the stages here are okay. So the only thing that we have to check out is I'll check the diode and make sure it's okay. It might be blown, and I'll see how the audio output section of the radio is. So here I'm going to check the diode. The diode is right here, and I'll bring down the meter so you can see what it says. That OL just means, so that diode is 0.356 in one direction, and if it's good, a good germanium diode will be infinity in the other direction. So the diode is good. So now what I'll have to do is inject a signal at this point here. Well, actually, I'll probably put it on the other side of the electrolytic capacitor. So I'll see if I can hear anything coming out of the speaker. That'll tell me that these transistors are okay. All these transistors are good. So I'm just going to have to inject it in here. It might be that electrolytic capacitor is just completely shot. So, which I don't have any doubts that it is. So anyway, that's what I'll do. I'll inject that signal. So here I'm injecting a signal into the diode on the other side, where it goes into the capacitor, and that's 0.5 volt peak to peak, 1 kilohertz sine wave. And when this is, I'll show you here. I'm injecting it into here, so it goes through the volume control. So here the volume control is at minimum, and I turn it up, and it's not doing a proper job of controlling the volume. So I think that's due to the capacitor being in poor shape. So I'm going to have a look at that. Oh, incidentally, earlier on in the video, when I was describing how the transistors came around on the lower side of the circuit board, actually what's happening is the transistors are in sockets. That's why they looked funny when they were being, this has been taken out. Now I'm going to put it in here, into this transistor tester. And I like working on radios that have, if you could see it there, just move this, there. I like working on transistor radios that have sockets because it's so easy to take. You don't have to unsolder the transistors. Yeah, that one is okay. Hardest thing is putting them back in this socket. You have to have good eyes to do that. I'm fairly lucky. I still have good eyes. Not that good. There we are. Now I'll use some pliers here, oversized pliers, to look at the two audio output transistors. See how the transistor, you have a gap here? That makes it much easier to put it into the socket. Emitter base collector. That one's okay. One good thing about this type of transistor is it can easily be replaced. I have lots of 2SB and 2SA PNP transistors. The Japanese, for some reason, in the 60s, went into almost exclusively PNP transistors, so I have lots of them that I've removed from old equipment. So if any of these need to be replaced, I have lots of them. 2SB will replace these. 2SA is an RF transistor. 2SA is an RF PNP transistor, and 2SA is a AF or audio frequency transistor, and 2SC is an RF NPN transistor, and 2SD is an audio NPN transistor. But you'll find in germanium, in Japanese radios, it's almost always PNP. So I'm going to check the final transistor, the final push-pull transistor. See if I can show it there. It's testing, and it's okay too. So we don't have any bad transistors in the audio section of this radio. So we've got all the output transistors seem to be okay. The diode's okay. I'm feeding a signal into the output circuit, and it even goes into distortion. We seem to it's not boomingly loud, but it's fairly loud. There. That's not as loud as the transistor radio would be capable of, but it shows that it's reproducing the signal without a whole lot of distortion until you turn it really high up. So I think the problem is there's a bad connection or a resistor that's gone. I'm going to replace these electrolytic capacitors, and then I'm going to see how it works. Then I'll test the other transistors. They could be amplified but not working very well. So that's what we're going to do. Replace all the electrolytics. That'll be the next thing. So I'm going to be checking the capacitors, and you can probably just see that little one down there. That one right there. I'm going to take it out and I'm going to check the value. That's the coupling capacitor that goes to the volume control. So I'll check that out, and we'll see what the ESR is and the value. So here I've taken one side of the coupling capacitor out of circuit, and see if I can bring it down a bit so you can see it a bit better. Here, look at that. A little bit over here. So there you'll notice is that it's supposed to be 3 microfarads, and it's 4.572. That alone would make you think it wasn't in very good shape, but the ESR, which is the effective series resistance, is 23.4. So that is not passing much of the signal. That's very high for a capacitor, so that capacitor needs to be replaced. So I've replaced that capacitor there, the coupling capacitor, and it didn't make any difference to the performance of the radio. I'm still not hearing anything. So I'm going to start, let me just turn this off here. So I'm going to start replacing these two, and then this one, because they'll have to be changed anyway. They'll be out of tolerance. So I'm just going to go ahead and replace them, because they could be, like for instance, excuse me, this one here, because it's if this is shorted, it would take a lot of the current this way, and the gain of this would go down. So that's one thing. If this was shorted, it would wouldn't get enough voltage on this transistor here. So that would cause, both of those leaking would cause the gain of this transistor to go down to almost nothing. One, because the voltage here is too low, and voltage on the collector was too low, and this one here would bypass current that should be going through here. So anyway, I'm going to replace both of those and we'll see what happens. I've never seen that before. I took this, I thought there were two separate 50 microfarad capacitors, but this is like in older radios where you have a ground and two positive leads. Interesting, I've never seen one this small before. It's only 50 microfarads, 6 volts. Anyway, I'll measure it and see what the ESR and values are. Okay, one is 32, one side's 32 and the other's 64. There's 64 and 65, and the other one is 28. The other one there. 64. And the other one is 65. So they've both gone high. I'm not even going to bother with the ESR. I'm just going to replace them. So that is another one that is shot. So I've replaced these two 50 microfarad capacitors as well as the coupling capacitor. Now the last one I'm going to replace is this little one in there, the 16 microfarad 3 volt capacitor. I don't have that value, so I'm going to have to replace it with a 22 microfarad capacitor. This one here shouldn't make a lot of difference. The coupling capacitor was, I believe, what it said on the schematic was 3 microfarad 12 volt. I didn't have something that close, so I had to replace it with a 10 microfarad. The only effect that will have is that it will it'll change the tone a little bit, probably give it a deeper tone once I get it working. Anyway, so I'm going to replace that 16 microfarad capacitor, and if that doesn't fix it, I'm going to check these transistors, the IF transistors and the mixer. So here are the 3 capacitors I replaced. Last one I replaced was down in here. That was the 16 microfarad, and I turned it on and I don't hear anything. So I'm going to feed a signal into it and try that again, and then I'm going to check all these, the 2 IF transistors and the mixer with a transistor tester. So maybe you can't read that, but I'm checking, whoops, right there. Anyway, this transistor here is okay. This one here is okay. That's the second IF transistor. Here I've checked the first IF transistor and it's okay too. Take this out and see, put it back in again. These easily get crooked and they don't go into the transistor socket easy. So let's see if I can get it aligned here. There we are. Now the mixer transistor. Give that a trick. Give that a try. So the mixer transistor is okay too. So now I'm going to have to look through for bad connections. I'll check voltages on all the transistors first. Well, I'm feeding a signal in and is doing exactly the same as it did before. I don't think that coupling capacitor was really that bad, but just in the interests of restoring the radio, it's best to replace it. So now we're going to check those transistors. Turn off the radio. Remove the clip leads. So maybe you can't read that, but I'm checking, whoops, right there. Anyway, this transistor here is okay. This one here is okay. That's the second IF transistor. Here I've checked the first IF transistor and it's okay too. Take this out and see, put it back in again. These easily get crooked and they don't go into the transistor socket easy. So let's see if I can get it aligned here. There we are. Now the mixer transistor. Give that a trick. Give that a try. So the mixer transistor is okay too. So now I'm going to have to look through for bad connections. I'll check voltages on all the transistors first. So I started checking the voltages, and on the transistor, the first stage here, the mixer transistor, I'm measuring 2.65 volts minus 1.27 on the base, and on the emitter 1.15. So 1.15 and 1.27, that's pretty reasonable. You want to see about 0.2 volts between the emitter and the emitter and the base. So here on the second one I'm seeing 0.62 volts on the emitter, 0.79 on the base, and on minus 2.65 on the collector. So the third transistor is minus 1.44 on the emitter, 0.32, 0.32, let's see, try that again, 0.32 on the base, and on the collector I'm getting 2.65. So minus 1.44 on the emitter and 0.32. That's more than a volt difference. That means that's a floating emitter. And the fourth one, I'm getting on the emitter minus 1.45. The base is minus 1.58, and on the collector I'm getting this 2 volts. So the third transistor, the base is somehow disconnected, or there's a bad resistor there. So just move this out of the way here, and just turn that off for a sec. So here in the schematic, the third transistor, the base goes into an IF coil. There's a 0.02 that grounds it, AC ground, and then it comes up to a voltage divider consisting of 27K and 3900 ohms. So I'm going to check that voltage there where they come together. This could be shorted, taking that to ground, or this could be open. So I'm going to check this first, see for continuity. So I'm taking and doing continuity checks between the base at 0 and there seems to be a break in the continuity in that IF transformer. And on the other, let's see on the, yeah, on both sides there's a problem with the IF transformer. So that transformer is busted. It's open. So I think I have a replacement for that in a junk radio, so I'll just have a look and see. I checked the other radio, and it's a Zenith, but it's a much smaller IF bin. So I'm going to see if I can take this out. First I'm going to resolder the connections here, see if it makes any difference. If that doesn't work, I'm going to have to take this IF bin out and see where the break is in the wires. I was measuring it wrong. Normally in most IF transformers it would be from here to here and here to here. Actually, that I'm measuring something now. Getting some continuity there now. Anyway, seems to be a dead short across there, but here there seems to be continuity now. So I'll just try it. I think that there's a short in this somewhere, so I'll turn it on and see if it works. If it doesn't, then I'm going to take out this IF bin. It might be shorted inside, so these bigger IF bins can be fixed. So I'll just pull it out and check, turn it on, see if I'm getting anything. No. Okay, so I'm going to take that IF transformer out now. So now I've got the IF transformer out, and there seems to be, according to the schematic here, you got 3 pins here. It's hard to see in the thing here, but according to the schematic there should be continuity between those 3 and continuity between these 2 on the other side, but there is something weird because there's continuity across there and there from opposite ones. So I'm going to have to take this apart to figure out what is going on. It's very strange. I've checked the other IF transformer, this one here, and there seems to be continuity across here and here and between here and here. So maybe there's nothing wrong with this one, so I won't open it up. I'll just check and see what resistors are, if they're giving the right voltages. I'll just check and see. Probably a resistor problem. Anyway, I'll just go through it and see. So I've gone back to injecting the signal into at various stages. So what I'm doing now is I'm injecting a signal right at the collector of the 3rd transistor, right here, a 455 kilohertz signal. Here I'm varying the frequency. Now, if I go to the base of the transistor, I don't hear anything. So for some reason the signal is not getting past this transistor, and yet this transistor is good. So I'll have to do some checks here. This IF, I'm going to check and see with it in circuit. I'm going to see if I can get a signal through here. I'm going to put the signal generator here and the scope here and see at the base and see what I get. So here I'm taking a signal from one side of the IF transformer. Here I'm feeding it in, and that's let's just put that back on there. That's approximately a 455 kilohertz signal, and on the base of the transistor I'm seeing just basically random signal. Even if I auto set it, it doesn't there it is, but it's it seems to get, it gets big at another frequency. So at 455 kilohertz is not passing much signal. So I really do think there's something wrong with that IF. I'm gonna have to take it out again. So here I've got the oscilloscope hooked up to the IF bin, and I'm feeding a signal through the IF transformer, and I'm just sweeping back and forth. There's 400, there's 500, so it is working properly. It is acting like it's supposed to. It's a little low, but that's easily adjusted. It's peaking at 449. Should be 455. So once this radio is put back together and working, it will need an alignment. So that is not giving me any, it just isn't telling me what is wrong with this radio. Why is the signal, it's not making it, it seems like it's not making it through this, and it's not this here. This is a transistor. I'm feeding a signal into here and it works fine. Feed a signal into here, it's lost. So it's lost in here. Maybe there's a broken connection somewhere around here. Seems to be passing through this okay. I'm going to feed a signal into here and see if it gets through this IF transformer and that transistor. That's what I'm going to do next. Right now we're looking at the signal, the mixed signal, which comes off, here's the oscillator, and we're looking at the mixed signal right here with the local oscillator and the incoming signal. So we're looking at the mixed signal before it's filtered in the 455 kilohertz IF bin and passed on to the next transistor. I can't show what's on the output of this transistor because it's not hooked up to VCC, which is the negative voltage that it needs to work. So I'm just seeing if this is being passed through to the base of the next transistor. It's hard to, whoops. Oops. I lost the end of the oscilloscope probe there, but here it's almost undetectable, the signal coming through there. So I'm going to have to put that IF transformer back in and see if this transistor here is amplifying it, so I can look at it at this point. So anyway, I'm just going to put that back in again because there doesn't seem to be anything wrong with that IF transformer. So I thought I would do a DC check of the IF bin that I've taken out, and the only place that I'm measuring any continuity, even though they'll pass the signal through it, is here. Right here, from here to here. That's the only place. 5 and 4, those are the only two places that have any continuity, and it's about the right right amount. But I'm not getting any continuity here to here or here to here. So I'm going to see if I can take that apart and see if there's any broken wires. It will not be an easy thing to do because the IF bin, it doesn't have a very, it's not like the bigger ones which can easily be taken apart. I'm going to have to do this very, very, very carefully. Here we are. I got the actual coil out of the IF bin, and now I'll just check it for continuity inside. It could be that it's just come away. Here you can see the internal structure. It could be that the coils have just so I had made a major error. I should have been looking at this IF bin and looking at these resistances between the pins, because these two were not on the right hand side and these were not exactly on the left hand side, even though they were in a row. So what I did was, when I had it out, I found the pins that had approximately 0.8 ohms, and then I measured. There was approximately 14 ohms between this. Actually just under 12, but it should be 12, but I measured 14. But the resistances complemented very close with these, so I realized that there's nothing wrong with this. So I put it back in again, and earlier when I had it out, I resoldered the connections inside, and now the voltages that I'm getting are right, except for here I'm measuring, at the base I'm measuring 0.74 volts, which is, it says 0.6 volts. At the collector, let's see here, collector I'm measuring building up -4 something, and at the collector -4 something, it should be -5.2, and down at the emitter it should be 0.43 volts, -0.43 volts, and it's measuring -0.215. So the emitter voltage doesn't make any sense. The collector is fairly close. Well, it's up there. It should be about a volt more than that. But these screwed up voltages, I'm beginning to think that there's a crack in the board. And guess what? I found one right here. Let's just move it a little bit so you can see that. There's a crack in the board between here and here. So, and that's a possible crack. Maybe a few others. This radio has been dropped. I should have assumed that from the start. So I'm going to resolder the whole board, just to be on the safe side. I'm going to bridge that with a piece of wire, and then I'm going to see how the radio, if it works. Because there's nothing worse than trying to figure out voltages in a radio that don't make sense, and then you find out it's cracked boards, cracked lands on the board. So that crack was the cause of the radio not working, but I just resoldered all the joints just to be on the safe side, so it doesn't stop working in the future. So now everything on there is shiny. So I'll just put the radio back together again and show how it works. So here was the problem, was a break right here, which I didn't notice. It looked like it had solder there. So paying attention to detail is so important. Even though I had gone over this radio, I looked at that circuit board and I didn't see any breaks. Just shows you hold it up to a good light and you just examine everything. The radio has an excellent tone, and it's very sensitive. Even picks up stations many miles away in the day. To see here, I'll show you what I intend to do now. The radio has a few cracks in it, and right there, you can see that, and there. I'm going to see about if I can fix that, if I can get some of this plastic repair kit that is that color. But the main thing I want to do is put, I think this was probably gold. So I'm going to paint this gold, or put a little layer of Mac Tech on there that's gold. So it'll be the next thing I do. But other than that, the radio is really working well. And I'm glad that we had a successful conclusion to this repair.